Hello friends, today we are going to discuss one of the important topic, metabolism of amino acids, specifically about transamination and deamination reactions. Yeah, transamination and deamination reactions are the common reactions for all amino acid metabolisms, and we can say it is a central point or the basic theme for all amino acid metabolic reactions. Okay, metabolism of amino acids, metabolism of amino acids, common reactions. That means transamination, deamination. You know, the objective of transamination and deamination, the major objective is to remove ammonia, which is a toxic compound, in the way of urea through urine. Because so it's a regular process. And regarding the basics, we all knew that proteins are the most abundant organic compounds, and it occupies a lion's share with respect to an adult dry weight, say 10 to 12 kg in a body of adult is because of protein. And proteins are dynamic in nature. That means static function like collagen and versatile dynamic functions like enzymes, hormones, etc. And regarding the basic building blocks, proteins are nothing but they are the polymers of L-alpha amino acids. We have discussed at length about these things when we have discussed about amino acids. Okay, I'm not going to the deep, just I'm giving a glance about different things. Okay, and regarding other issues, amino acid pool. When we discuss about metabolism of amino acids, we have to learn about amino acid pool. What makes an amino acid pool? They are nothing but free amino acids. Say about 100 grams of amino acids will be present in an adult human being, and these amino acid pool will be make up based on different sources, what we call inputs. Say total body protein turnover, what we call simply body protein turnover, then dietary sources, then a synthesis of non-essential amino acids. These are the three inputs through which the amino acid pool will make up. It is around 100 grams, and the same will be utilized for different ways. Say for example, we knew that proteins are building blocks, then synthesis of non-protein nitrogenous biological active compounds. Say for instance, porphyrins, peptidines, purines, melanins, etc. These are all different compounds as they have different essential metabolic functions. At the same time, about 10 to 15% of body's energy requirements comes from oxidation of amino acids. That means they are also utilized for energy generation as well. At the same time, they also act as precursors for glucose and fats, and ultimately they are also useful in the synthesis of non-essential amino acids. That means on the one hand they are called inputs, other hand they are called outputs. That means different ways that these amino acid pool will be utilized. Okay, amino acid pool, what we call amino acid pool. That means body amino acid pool is nearly 100 gram in an adult. Okay, 100. It will be constituted, that means different ways, inputs that made up this amino acid pool. That means this made up this 100 grams around of amino acid pool. Say body protein turnover. Body protein turnover. It is around 300 grams per day in an adult. Around 300 grams per day. More specifically, 300 to 400 grams. 400 grams per day in adult. Okay. And it will, these are two ways. One, degradation. Two, synthesis. That means around 300 grams of body proteins will be degraded, at the same time will be synthesized. 300 to 400 grams, what we call body protein turnover, and is one of the input for amino acid pool. Okay, one of the input. Next, dietary sources. Dietary sources. Dietary sources. The word it implied, we have to get through diet, and it is said that around 30 to 50 grams of protein will be degraded daily in an adult human being. Around 30 to 50 grams of protein per day will be degraded. The same we have to get through diet, what we call balance of N content, nitrogen content, and this is essentially through external source, dietary source, to made up these nitrogen sources. Okay, and to counter these we have to get to dietary sources, and it is one of the source for amino acid pool. And the third source is synthesis of non-essential amino acids. Non-essential amino acids. We knew that we have 20 amino acids which will be recognized by the genetic code. 10 are non-essential, 2 are semi-essential, and 8 are essential. For example, histidine, valine, isoleucine, leucine, lysine, threonine, tryptophan, methionine, these are all essential, out of which arginine and histidine are semi-essential, because these two cannot synthesize by the children, but an adult can synthesize. It's like 10 plus 2 plus 8 pattern, okay? But we can synthesize only non-essential amino acids, okay? So all these made up to amino acid pool. And it is said that average, that means a recommended level of protein intake is 1 gram per kg per day. In most of the country, the daily protein intake in an adult is like 40 to 100 grams per day. What we call protein intake. Okay, these are all about different inputs, sources, and how it will be utilized. That means these constitute amino acid pool, and how it will be utilized. It will be utilized now, as we said, for protein synthesis. Say the free amino acid will be utilized for synthesis of protein, because they are the building blocks of proteins. Then number 2, for energy generation, we already discussed that 10 to 15% of body's energy requirements comes from oxidation of amino acids, and they also serve as precursors for glucose, fats, and ultimately in the way of urea through urine it will be excreted, what we call output. That means they are the input that made up amino acid pool, and they are the ways that we can utilize for synthesis of glucose, fats, the way of urea, energy requirements, of course, the non-essential, synthesis of non-essential amino acids. These are different ways. And this is very important because ammonia is a very toxic component. It has removed, that means say through urea to urine, that means what we call urine linkage. So it's about different ways, that means what we call central theme of amino acid pool. Central theme for amino acid pool. They are nothing but free amino acids. Okay, it's about that. And the same will be subject to metabolism in different ways. We have discussed for energy generation, for fat, for glucose, and for essential synthesis of non-essential amino acids, and like that. Okay, what we call amino acid metabolism. We have to learn about what we call an overview. We have to learn through a glance approach so that we can understand at least the basic sense. Okay, then before we go into the topic, we have to learn these things. Okay. Regarding overview, amino acid metabolism. It is a common pathway for all amino acid metabolisms. Okay, we have discussed already amino acids. Amino acids. What are its sources? Say body protein, another source. Then dietary protein, another source. And how it will be utilized for synthesis of protein synthesis, protein synthesis, and for N compounds, what we call non-protein compounds. Say, for instance, porphyrin, purines, pyrimidines, etc. Okay. And these amino acids, it is in general pattern. Excess, when they get generated, that means when they will be utilized, that means what we call different threshold levels. If we get excess amino acid intake, that means access to the body's requirement, the same will be utilized in different metabolic ways. Say, act as precursor for glucose, and act as precursor for fats, like that. Okay. Say these amino acids we have discussed in sort of transamination reaction. Transamination reaction. The central theme is through conversion of alpha ketoglutarate to glutamate, and this it also includes, that means simultaneous data includes synthesis of keto acids, what we call alpha keto acids. We have discussed, we utilize for the synthesis of energy generation, act as precursors for glucose, for fats, then for non-essential amino acids, and the glutamate will be deaminated, what we call deamination. Deamination is the first and the second reaction that leads to generation of ammonia and through urea and through urine. Okay. This is called a general overview of amino acid metabolism. We have discussed amino acid pool will be coming from body proteins, dietary proteins, useful for synthesis of proteins, and also for non-protein important nitrogenous compounds like porphyrins, purines, pyrimidines, melanine, etc. Okay. Then transamination, deamination. Transamination means we will get the most important reaction just for now. Okay. Alpha ketoglutarate becomes glutamate, and this glutamate amino acid become deamination. Subject of deamination will get ammonia, and ammonia will be utilized in the synthesis of urea, and the urine it will be generated. It will be removed out, excreted. That means the end product of protein metabolism is urea. What we call end product. Okay. Then the keto acids we will get simultaneously. The same will be utilized for either energy generation. That means what we call multi-dimensional metabolic pathways. Depending on the requirement, say if there are excess, they may be useful for glucose synthesis, that means fats, or even non-essential amino acids. So these are different ways, metabolic fates of keto acids. It depends on the requirement and depending on the number of, it's like whether we have excess amino acids or not. If we have excess amino acids, they will act as precursor for synthesis of glucose and fats. Okay, it's about the basic amino acid overview of basic amino acid metabolism. Let us get in the main topic, what we call transamination reaction. Transamination reaction. The first important component, transamination reaction. Here it means transfer of amino group from amino acid to keto acid is transamination. For example, how it will take in general, I am saying, okay. This is one amino acid, then it will become keto acid. This is another, is one keto acid. Let me say this is amino acid 1, and this is keto acid 1. Most important is transaminase enzyme. Transaminase. And most important coenzyme associated with transaminase is pyridoxal phosphate, what's called PLP, a coenzyme derivative of vitamin B6. This is very important aspect, okay, in examination point of view. PLP, pyridoxal phosphate, you know, and I will tell you how it ends. Okay, this is another keto acid. This is keto acid one. Okay, this is another keto acid. Then we'll get final. This is another amino acid. Keto acid one. Then amino acid 2. Sorry. Okay. That means the thing is the most important component we have discussed point by point. Transamination, that means the word it implies the transfer of the amino group from amino acid to keto acid. Amino group from amino acid to keto acid. Okay, amino acid to keto acid. It's a reversible reaction. It's a reversible reaction. We have to discuss about general perspective, then we can get to the details. Okay, the general representation of transamination reaction. It is a reversible reaction, and most important enzyme is transaminase, and the most important compound, the coenzyme PLP, pyridoxal phosphate, which is a coenzyme of vitamin B6. Yet, transaminases can also be considered as amino transferase. Amino transferase. And the thing is, it involves one pair of amino and keto acids. That means one pair of amino acids and one pair of keto acids. What we call interconvertibility. Here, the amino acid by losing amino group will become keto acid. And a keto acid by accepting amino group will become another and it become amino acid. It's like amino acid to keto acid, and a keto acid by accepting amino group then become amino acid. It's called interconvertibility of one pair of amino acid and one pair of keto acids. And to mediate this, what we call this like facilitator is PLP, pyridoxal phosphate, a coenzyme of vitamin B6, and the enzyme is transaminase, otherwise called aminotransferase. This transaminase, with the help of PLP, will transfer the amino group for amine to keto acids respectively. That is a whole, that is called the crux point for transamination reactions. Okay, and it involves one pair of keto acids and amino acids. Okay. Regarding general aspects, we have to discuss about. Okay, and transamination reactions are the most important amino acid metabolic, common metabolic reactions. You know, we have discussed all amino acid metabolic reactions have to subjected to transamination and deamination. And this transamination is most important for, you know, what we call shifting or shuffling of amino groups from one to other compound. That leads to a synthesis of non-essential amino acids. It's very important. Synthesis of non-essential amino acids. And it's a reversible reaction we discussed. And another important component is this. It doesn't mean that only alpha amino group will be involved. Here, delta amino groups. So for example, a delta amino groups of ornithine will also takes place in the transamination reactions. And this transamination reaction will take place in two steps. Number one, the transfer of amino group from concerned amino acid to PLP, pyridoxal phosphate. Then transfer of the amino group from pyridoxal phosphate, that means which we get pyridoxal amine. That means PLP become pyridoxal amine phosphate. PLP become pyridoxamine phosphate. Pyridoxamine phosphate, the word it implied, it contains amino group. And this pyridoxamine phosphate will transfer amino group to another keto acid so that it will become amino acid, second amino acid. So one pair of amino acid and keto acids. And most important thing is specific. These transaminases are, that means for each pair of amino acid and keto acid there are specific transaminases. and most important contributors are aspartate transaminase and alanine transaminase. Though we have different transaminases, that means specific transaminases, but aspartate transaminase and alanine transaminase contributes a major role in the amino acid metabolisms. Then, and most important thing I have discussed already, PLP, pyridoxal phosphate, when it takes amino group from the first amino acid become pyridoxamine phosphate, and this pyridoxamine phosphate will transshift, that means the transfer amino group to another keto acid, so it becomes another amino acid. How? The interconvertibility of one pair of keto and amino acids will take place through transamination. What we call transfer of amino group from one, that means from amino acid to keto acid. This is very important. For all this, ultimately to get glutamate, or I'll tell you how the issuance. Okay, it's about the general representation of transamination reactions. Okay, specifically we can take one example. We already discussed transamination will take place in two steps. So take for example alanine, and it's a reversible reaction. Okay, the enzyme is specific transaminase enzyme, glutamate pyruvate transaminase. We'll get pyruvate. We already discussed PLP. That means pyridoxal, PLP. Pyridoxal phosphate. It has to become pyridoxamine phosphate. That means alanine become pyruvate by shifting the amino group NH2 to PLP, so that it become pyridoxamine phosphate. That means NH2 group it will shift so that it become pyridoxamine phosphate, and this pyridoxamine phosphate again become pyridoxal phosphate. We have discussed a reversible reaction by transferring this amino group. By transferring this amino group another keto acid, what we call alpha keto glutaric acid. Alpha keto glutaric acid. That means alpha keto glutaric acid accepts amino group from pyridoxamine phosphate to become ultimately glutamate. The same enzyme here also. Glutamate pyruvate transaminase. And this glutamate, this is called transamination. No, from alanine, it become there is a transfer of amino group from alanine, so that it can become pyruvate. That means simultaneously get keto. That means the carbon skeleton of amino acid become keto acid. The fate of keto acid we have discussed. It may be useful for the energy generation, or as a precursor for glucose, fats, even for instance of non-essential amino acids. Okay, by appropriate metabolic pathway. And here the mediator is PLP. This is very important. That means a coenzyme of vitamin B6. Enzyme is glutamate pyruvate transaminase, and its coenzyme is pyridoxal phosphate. By accepting amino group become pyridoxamine phosphate, and this pyridoxamine phosphate shift that means transfer the amino group to another keto acid, alpha keto glutaric acid, so it becomes glutamate. Then again we have regenerated pyridox. This continuous regeneration of pyridoxal phosphate is essential for the successful continuity of transamination. This is to regenerate this, because the key points like regular regeneration reaction. So it will take place in two steps. The first is PLP formation. That means PLP become pyridoxamine phosphate, and the second one is pyridoxamine phosphate transfer amino group to keto acid, so that it becomes second amino acid. So two-step reaction. First, the transfer of one, just it be here the alanine. We have taken specific example. Amino group from amino acid to PLP, pyridoxal phosphate, so that it become pyridoxamine phosphate. Then it will transfer to another keto acid, so that it become another amino acid. See here, and the thing is, another amino acid means glutamate, collecting compound of amino group. This is a very important point. You know, only glutamate is the amino acid which is considered as the collecting point of amino groups, what we call concentration of N through glutamate. No other amino acid will get through. So it's like all the ways to Rome. Any amino acid metabolism have to get to glutamate, and this glutamate will undergo deamination, what we call oxidative deamination, to get ammonia NH3, then synthesis of urea, and will extract the urea. This is very important. This is a mechanism. Glutamate is a collecting central, what we call central molecule for transamination. This is very, very important. Glutamate is a central molecule for transamination, whereas PLP is an important coenzyme in transamination. PLP stands for pyridoxal phosphate. PLP become pyridoxamine phosphate. With respect to CSR examination and other equivalent examination point of view, these two are important. Okay, this is about transamination reactions. Okay, next deamination. Now, before we go into the main topic, we have discussed about, it's like shift base. We have discussed about this shift base or imine linkages. This is with respect to PLP, pyridoxal phosphate. This is very important. We have discussed it is a coenzyme of transaminase. How it binds? The aldehyde group of pyridoxal phosphate binds with the epsilon amino group of lysine residue of the enzyme. And this is in general. When the amino acid substrate comes in contact with the enzyme, it will replace the enzyme. What we call, this is called a amino acid PLP residue, what we call imine linkage or shift base or imine linkages, what we call. Shift is the name of the chemist who first identified this. Imine linkages mean imine compounds are such compounds which contain azomethane linkages. That means CN that attaches to carbon or hydrogen. Here simply what I mean to say is, so this is PLP, pyridoxal phosphate, the aldehyde group, it links with the epsilon amino group of lysine, and this is enzyme. That means how the PLP attaches to the core enzyme is through aldehyde. That means the involving the reacting compounds, the aldehyde of PLP and the epsilon amino of enzyme of lysine residue of enzyme. When amino acid comes here, it will replace it. And this amino acid PLP link, amino acid PLP shift base, what we call shift base, tightly binds with the enzyme by non-covalent interaction. Okay, non-covalent interaction. In examination, they may ask you what is shift base and how it formed. It's between PLP and the enzyme. And what is the important involving component? It's about the aldehyde group of PLP and the epsilon amino group of lysine of the enzyme transaminase. When amino acid comes, it will replace it. This is about the transamination reactions. Okay. Next important, deamination. We got it. Glutamate. This is very important. I have discussed the central element. Okay. Glutamate. The deamination, the word it implied, removal of ammonia, that means removal of amino group from amino acid in the form of ammonia. That means removal of ammonia from the amino group of amino acid. Removal, deamination. Deamination. Removal of amino group from amino acid in the way of ammonia is deamination. We have all discussed glutamate is a central element and it will be subject to deamination reaction, and NH3 urea and urea. This is the pathway. It is of two types again, oxidative deamination and to non-oxidative deamination. Non-oxidative deamination. And oxidative again of two ways, glutamate dehydrogenase, what we call GDH. Glutamate dehydrogenase. Glutamate dehydrogenase. Here another one is amino acid oxidases. Amino acid oxidases. Here non-oxidative, there are different enzymes like dehydratases, desulfohydrases, and histidases. Okay, amino acid oxidase